Okay, everybody, one last bit about these properties of trigonometric functions of real numbers. In this case now, we've got fundamental trigonometric functions, trigonometric identities. Well, this is what we call identities right here. An identity, remember, is the kind of equation in which we can say that the expression is always true for every value of t that we put into the function. So we have three sets of properties right here. First of all, we say the sine of t is equal to 1 over the cosecant of t. Well, yes, we actually have stated this in the past, maybe not in so many words, but if we're looking at a unit circle and we have some coordinate point xy that's associated with an arc length t, that's y, that's associated with an arc length t, what could we always say about it? Well, if sine of t is equal to y, cosecant of t is 1 over y. Therefore, they are reciprocals of one another. Cosine of t and secant of t are the same thing. Cosine of t is the x, secant of t is 1 over x. They're reciprocals. Tangent is y over x and cotangent is x over y. So by those definitions, right there, we can tell you that our sine, cosine, and tangent are reciprocals. A little bit harder might be these ratio identities, but in fact, not so hard to believe. Why? Well, sine of t we set as y on our unit circle. Cosine of t is equal to x. So tangent of t would be y over x, which is sine of t over cosine of t. And cosine of t is equal to cosine, cotangent of t is cosine over sine of t. Cosine we said was x. Sine was equal to y, and we know that x over y is our cotangent of t. So that actually verifies it. Now we have this third one that's a little bit harder, but actually not so bad. We happen to know that because we are in a unit circle, that it turns out that x squared plus y squared is equal to 1. And by our definitions, we said that for some arc length t, x is equal to the cosine of that angle t, and y is equal to the sine of that angle t. So what could we say? Well, if x squared plus y squared is equal to 1, then sure enough, sine t and cosine of t squared, the sum of their squares, will also be equal to 1. That only makes sense. But let's try an experiment. Let's take this equation right here, x squared plus y squared equals 1, and divide everything by x squared. What happens? Well, if we divide everything by x squared, check this one out. X squared divided by x squared is 1. Y squared divided by x squared is y over x quantity squared. And 1 over x squared is the same thing as 1 over x squared. Well, 1 over x is our secant, y over x is tangent, so 1 plus tangent squared x plus 1 plus tangent squared t plus 1 is equal to secant squared t. By the same token, if we divided everything by y squared, what would happen? Well, this would happen. X squared over y squared, well, that's x over y, which happens to be cotangent. When we square it and add it to 1, that's equal to 1 over y quantity squared, and 1 over y is the cosecant, and therefore this is our third Pythagorean identity, and that's true. All right, so how might we use these properties? Well, here's an example right here. Let's say we're asked to write the expression sine of squared theta plus cosine squared theta plus tangent squared theta as a single term. What could we say? Well, we just looked at our Pythagorean identity. Our Pythagorean identity said that sine squared t plus cosine squared t is equal to 1. Well, there's 1 right there. So we've actually got 1 plus tangent squared theta. That's kind of handy to know. But what about 1 plus tangent squared theta? Can we whittle that one down? Well, sure enough, we go back right here, we said if we had 1 plus the tangent squared, we're going to get secant squared. And so this is equal to the square of the secant of theta. That's kind of cool. Well, how about this one? We say, well, let's take tangent of t and write it in terms of cosine of t if t is somewhere between pi and 3 pi over 2. All right, well, we need to actually mark pi, 3 pi over 2, and all of that. Okay, so I marked up my unit circle in terms of that. So if t is between pi and 3 pi over 2, it's actually telling me that I have an arc length that is somewhere over here in the third quadrant, right? So here's where t is located. So what could we say? Well, there's a relationship right here. And in this particular case, we've got x and we've got y. X and y are both negative values right here. We have 1. If tangent of t is to be written in terms of cosine of t, right, we might note this relationship that tangent of t is y over x. And what could we say about those two? Well, there is certainly a relationship that says x squared plus y squared is equal to 1. But if we want to find out what tangent of t is in terms of cosine of t, we need to somehow put this in terms of sine and cosine. Well, we know that y is the sine of the angle t, and x is equal to the cosine of the angle t. All right, so well, we've got it partly in terms of cosine of t, but we need to handle this business with sine of t. So what could we do? Well, the sine of t, we've said that there is a relationship between sine and cosine, and if we take the square of the sine of t and add the cosine of the square of t, we're going to get 1. Well, that would mean that sine of t, sine squared t, is equal to 1 minus the square of the cosine of t. So if we solve for sine of t in this equation, we would have to take the square root of the other side, but we have to take plus or minus. How do we know which one? Well, we're in quadrant 3, so it has to be negative. So we'd say 1 minus the square of the cosine of t. And so tangent of t, by this process, is got to be equal to the negative of the square root of 1 minus cosine squared t, all divided by cosine of t. And that would be our simplified expression right there, just what we were looking for. Okay, good luck on the homework, and I'll see you in class.